So you see that there are some branches coming from the cyclone, okay? You have a branch of one carbon that is called methyl and methyl. And here you have a branch of two carbons that is going to be called ethyl. Ethyl begins with E. Methyl begins with M, which means ethyl must be in the first position, okay? So here in ethyl is where I'm going to locate my first carbon in the cyclo, and I will start numbering according to the red or the blue path. And I will choose the path that gives me the least numbers. So I have one ethyl in the red path, also in the blue path. But then I compare. I have 3 and 2, or 2 and 3, for methyl, and I have 5 and 6 for the same methyl. So I will choose the path that has the least numbers, which in this case is 1, 2, 3, okay? So 1, 2, 3 is less than 1, 5, 6. We're going to choose instead the red path. With this, we should be able to name as 1 ethyl, 2, 3, 2, 3, dimethyl, because methyl is twice, and then we write the name of the parent chain, that is cyclohexane. Cyclo because it is a geometric figure, and hexane because it has 6 carbons. Okay, what to do in that case? Sometimes the cyclos are parent chains, just like we see over here, but some other times the cyclos are going to work as substituents. Working as a substituent, remember a substituent is the same branch or legs or attachments, okay, that are in a parent chain. So what to do in the case that a cyclo is part of a main of a main structure, okay? What are we going to do in that case? Let's take a look. The first thing I see, the first thing I notice when I see to this structure is that I have a beautiful pentagon right here. That's the first thing that I notice, okay? But how do we know if this is a substituent or a parent chain? To know that, we need to compare, okay? So let's take a look. I will compare amount of carbons. Carbons are what tells me which one is going to be the parent chain. So I need to compare which one it will be. So in the first place, I will start counting these carbons. I have 1, 2, 3, 4, 5, 6, 7 carbons right here. Okay? If I take a look to the figure, I know that here I have 5 sides, therefore 5 carbons. So, because here I have 5 carbons, Sorry. Because I have 5 carbons, I will see which one will be the parent chain. Remember, the definition of the parent chain is the longest but continuous chain of carbons, sorry. So which one is going to be the parent chain? The one in red or the one in yellow?
Red.
Red. That's important because this tells me that my geometric figure is not a parent chain. That's what this tells me. Okay, so this that I just highlight is my parent chain, and because it has 7 carbons, that parent chain is going to be heptane, not cycloheptane, just heptane, because this parent chain is not a geometric figure, it's just a chain of carbons. So what happens? This is my chain of carbons, but my pentagon is attached to it. The pentagon is attached to the main chain. So that means that this is going to work as a substituent or branch. I don't know how you want to call it. It's okay. So what happens here? Remember what we do. Okay? Remember what we do. Substituents is everything that ends in YL. For example, if you have a substituent with just 1 carbon in the end, it's called methyl. Okay? If you have a substituent with 2 carbons in the end, it's going to be known as ethyl. If you have a substituent with 3 carbons, it's going to be known as propyl. If you have a substituent of 4 carbons, it's going to be known as butyl, and so on. Okay? All I want to show you is that every substituent ends in YL. And because this pentagon is going to be working as a substituent, the name will change because it needs to end in YL. YL is just that suffix tells me that whatever I just mentioned is attached to the main chain. That's what it tells me. Okay? So, knowing this, I know, wait, knowing this, we're going to learn how to name this substituent. So take a look. It is a geometric figure of 5 sides. Okay? If because it is 5 sides, we call this pentagon. Okay? Like the military building in the United States, well, it is a pentagon. Now, because it is a geometric figure, the name will begin with the prefix cyclo. Okay? Because we're talking about a 5 corners figure, you're going to be using penta to indicate those 5 corners. Sorry, not penta, just pent. And then to indicate that it is actually a substituent, remember to indicate the suffix "il". And the combination of these three is going to give you the name of this substituent, which is going to be cyclopentyl. Now, remember what we do with the substituents. We always see the letter by which it begins. Question: by what letter do you think cyclopentyl begins? With C or with P? You can send it to me in the chat. With P. Very good, Ashley. That is correct. When we list alkyls, we are going to get rid of the prefix, and we will say that cyclopentyl actually begins with P, not with C. Just like we do with isopropyl, remember? When we do that with isopropyl, isopropyl begins with P. So this one will also begin with P from pentyl, because P is what defines the shape. P for pentyl tells me that it begins with P. Now, remember, I will write it here. Begins with P, not C. Okay? That is important. So, all this story to tell you that the pentagon that you have over there is gonna be called cyclopentyl. That's the big story, okay? Now, take a look to this. Because this pentagon now has a name, I'm gonna put it over there. Now, remember that we always do remember what we always do. From the parent chain, we're going to draw two paths, one red path and one blue path, okay? I already have the red path, so I continue with the blue path. Now, if I choose the red path, my name is going to start with 1. 1 cyclopentyl. But if I choose the blue path, my name is going to start with 7. 7 cyclopentyl whatever, okay? Which path is better for this molecule? Red or blue? With the blue, you get a number of 7. Remember that we always need to choose the path with the least numbers, okay? We choose the path with the least numbers, okay? So it's going to be red. Because 1 is less than 7, we're going to choose this path and we're going to finish writing the name. So we have 1 cyclopentyl, but then we also need to indicate the parent chain. The parent chain has 7 carbons, so this parent chain is going to be heptane. And this will be the entire name for this figure. 1 cyclopentyl heptane together, lowercase only. Now, you can write it like this, or you can get rid of the 1. Why can you get rid of the 1? Think about it. For example, when you have x raised to the first power, do you say x or do you say x raised to the first power? This
Only
is,
X.
you just say X, right? You just say X. When now to chemistry, going back to chemistry, how many molecules of water am I showing? Ah, esta cosa no actualiza nada. Going back to chemistry, X to the first power, in the end you just say X. But now here, how many water molecules I have here? How many? What tells me that? The coefficient. If you don't see the coefficient, what number is that?
1.
Invisible one, okay? So that means that even here in organic chemistry, you can see one cyclopentyl heptane or not, because one is invisible. We ignore it. You can skip the one if you want, okay? So that will be the name, the full name for this structure. Now, I want you to send me a message by telling me how much you understood from this first example out of 10. Okay, let's see, 7, 8, 5, 7, 9.5, 10, 8. So I can say that you understood 5.6. Okay, well, that's a weird number to say, but I get it. 5.67 out of 10. Okay, I'm gonna try another example. Pay attention to this one. What is going to be the parent chain here? Remember, the parent chain is the longest chain of carbons. So you need to compare. You need to compare where you have more carbons. In the substituent, you have 1, 2, 3 carbons. Okay? In the other chain of carbons, you can get 1, 2, 3, 4, 5, 6, 7 carbons. You can do it like this, or you can do it like that. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. 7 carbons either way. Okay, so which is going to be the parent chain, red or green? Obviously, it's going to be the red, because this is the parent chain. I will put it in a different color. Now, everything that is attached to the parent chain is going to be a substituent. So I have this substituent right here and this other right here. A substituent with just one carbon is called methyl. A substituent with two carbons is called ethyl. And now we need to work with this separately. Okay? I have three carbons and it is a geometric figure. It is a triangle. Okay? But I cannot write triangle over there. Okay? Because that is not the right name, at least in chemistry. This is not the good name. Okay? So don't write triangle. Now, this triangle has three carbons. And because it is a cyclic figure, the name is going to be composed of the prefix cyclo, the prefix for three carbons, plus the suffix YL, because it is a substituent. Now, what is the prefix for three carbons?
Pro.
As you said, it is prop, okay? So for three carbons, I will use prop. Now, I'm going to get rid of the plus signs, and this is going to be the full name for the structure that is attached to my parent chain, cyclopropyl. Okay? Now, I need to number the parent chain in the two ways. Red and blue. Okay? So this is going to be my red way, and this is going to be my blue way. 7 carbons, so the parent chain is heptane. Okay? It is heptane. Now, with what letter does cyclopropyl begins? With C or P? Exactly. It begins with P. So I will just indicate here P with a different letter, with a different color, just to remember that it begins with P. So alphabetically, which one comes first, ethyl, methyl, or cyclopropyl? Alphabetically, ethyl begins with E, methyl begins with M,
Cyclopropyl.
cyclopropyl begins with P. Acuérdense, vamos a ignorar este prefix de cyclo y nos vamos a concentrar en la palabra que indica mi número de carbons. Como aquí tengo 3 carbons, el prefix para 3 es prop y prop comienza con P. Entonces, this figure is going to begin with P. Just like in the example before, cyclopentyl, we say that it begins with P, not C. Also here in cyclopropyl also begins with P, not C. Okay, so I'm going to list the alkyls alphabetically. Ethyl comes in the first position, methyl comes in the second position, and cyclopropyl, which begins with P, comes in the third position. Now, what path is going to be better for the name? Remember that we're going to start with ethyl. So what path is going to show the least numbers? Red, exactly.
The red one.
Why? Why red? Because if you choose the red path, you're going to have 3 ethyl, okay? But if you choose the blue path, you're going to have 5 ethyl. And remember, when we write the names, we choose the path with the least numbers, okay? We choose the path with the least numbers. So, blue is not the case this time. We're going to focus on the red path. Okay, so I'm going to take it apart. So the name comes, it begins with ethyl, then we continue with methyl, which is in the position 2, in the red position 2. And then we finish with the cyclopropyl, which is located in the position 5. And in the very last part, what we do is we write the name of the parent chain, which is heptane. And this is going to be the full name. So, we see the parent chain, we identify the alkyls, the cyclos begin with the with the letter after the prefix cyclo, okay? And we order alphabetically. Ethyl comes first, methyl second, cyclopropyl third. So we choose the path where ethyl has the least number, which in this case 3 against 5. 3 is the least, which is the red path, and we name it with the red positions. 3-ethyl, methyl in the position 2, and cyclopropyl in the position 5, and then we indicate the parent chain, which is heptane, because we have 7 carbon chain. Here we have 7 carbons, and this is the way that we name structures with cyclos as substituents.